Imagine that we have different eyes. You can see different realities. So in this room, we're filled of waves that we don't see.
But it's around you, and it's behind so many applications of our modern world. What is the physics behind your way of sensing the environment?
What you see through your eyes is a very narrow part of the spectrum, which we call it the optical regime.
We only are able to see a tiny portion of what is called the electromagnetic spectrum.
And it's everywhere, from the radios, cellular bands, Wi-Fi. It is everywhere.
We are surrounded, let's say, by these waves that are propagating and bouncing and coming back and forth.
Yeah, so through the years of research, we have developed a different view of electromagnetic waves. We were able now to see the waves.
We cannot yet get full control of this information that is still out there in these waves that we said, but we don't know how to grasp it. These are two radars for weather, but we can also use them to look at airplanes and to look at drones, etc. And in this room we have the computers and the facilities to control them, but also read the data and start to process the data. So we work in microwave, say 1 gigahertz up to 100-ish gigahertz. The superpower of the microwaves are that safety and compactness, and also the possibility to propagate them very far. You can propagate through opaque materials, so through a wall, for example. What is really unique about our group is this ability to cover the whole spectrum, from really the physics and how to use the information. Without one of the two pieces, you're losing something. But data does not mean information. And you need to filter and refine, let's say, the information to correlate properties of the objects that you want to see to this raw material, these raw waves that comes back to you. And that is the challenge. It can have an impact on so many applications. So better forecast of weather phenomena, say security and safety or autonomous vehicles, down to healthcare applications. But there are still a lot of open questions, especially if you really want to squeeze more information and you want to deliver more capabilities to make sense of what's happening around you.
The terahertz is stuck in between these two bands, very well-established frequency bands, the microwaves and photonic bands. Most of our people have worked on space science, and that's where it all started. It came from scientists that wanted to understand the chemistry and the composition of distant planets and galaxies. It was very unexplored. We cannot detect it. We have not been able to use it for a very long time. There is very little technology that can cover this band. So it is a treasure hunt to find technologies that works on this regime. And that's what we do. We're trying to fill that gap. We're trying to develop technology, techniques to be able to use this electromagnetic wave. Everything that we need to build is very, very small. We're talking about dimensions that are in the micrometer level. We're making antennas and circuits that are as tiny as the diameter of our hair. We need to use a clean room, so there's no dust particles. You can fabricate very, very tiny features without disruption from air. TU Delft has state-of-the-art facilities, and we also have the people that makes us unique in this world. This makes it interesting because we're doing new things, we're doing new devices, we're doing new cameras, we're doing new antennas. And we do that through the mastery of electromagnetics. Terahertz waves have an industrial potential, better medical diagnostics, safer cars, faster communications.
There is a lot of synergy between these different applications. Yeah, they are very different on surface, but the fundamental principle can be shared. So the fundamental is still very, very important.
It's difficult to explain to the people what you do. It is one of the most complicated fields in physics. This will change how we connect to people.
That's what people that come to do engineering really want to do. Yeah.
You can do the impossible when you see the invisible. It is magic.